of it. So we're going to talk about index or exponential equations. There are three cases. The first case for index equations is where you just have something raised to some power, and I just put a P for power. It could power, exponent, whatever. It could be anything. Raised to the second, raised to the third, raised to the fourth, whatever. Doesn't matter. Equals something else. And usually that something else is a number. But you're going to see in the second set of things that we do that it doesn't have to be a number. Right now they're going to be numbers. Okay? Second case, okay, is where the exponent is, don't write exponent. I meant variable. Ugh. The variable is in the exponent. So in other words, it's like 2 to the x, right? Your unknown quantity is actually in the exponent itself, okay? Don't panic. They're not difficult. It's just a matter of staying organized to do them. And the third one is where you have inequalities with exponents. And again, these look difficult, but they're not. Literally, you're just trying to find a number. It's really easy. Inequalities. Greater than, is less than, those things. Remember those symbols? Or inequations, y'all call them, I think. Some of you. Inequalities, inequations. Sorry. Inequalities? Good. I like it when y'all use the right word instead of some Australian word. Sorry. Why do I record this stuff? All right. Shh. Sorry.
Do you edit your videos?
No, I need to.
Did you say sorry to the camera?
If anybody's listening to it later and they're offended by that. Okay. Now, it doesn't show. All right. Okay. Here we go. So let's look at some examples of the first kind and talk about what we're doing, okay? But before we do that, we can't do the opposite if we don't know what the opposite is, right? So, you know this. Even if you don't know, if you don't think you do. The opposite of an exponent is a root. And it can be, and the root, okay, it'll be the same root as the exponent. Okay? So we're just talking about unsquaring something, or uncubing something, or unraising something to the fourth power. Doing the opposite. Okay? And that means doing a root. And you know the root symbol, the square root symbol, or whatever root we had. We did this before in the algebra section, right? I mean, no, not the upside, that's year 12. Okay, sorry. So it's a radical. Right? It's called a radical. Or root. Now again, you don't even have to decide which radical to use, which root to use, because the exponent will tell you. Okay? So, let's look at an example. All right. Well, let's talk about steps first. First thing, isolate. What does isolate mean? Get it by itself on one side. Thank you very much. Excellent, guys. Isolate the square or cube, whatever. Okay? And it's the variable term always. It can be a square, it can be a cube, it can be whatever. Get it all on one side by itself. So if it's x squared, that x squared needs to be on one side by itself and everything else needs to be on the other side. Okay? Then, take the root of both sides. Because what we need to do is unsquare it or uncube it. And we do that by taking the root. And you can do anything you want to as long as you do it equally. So that means I can take the cube root of one side as long as I also take the what? Cube root of the other side. Okay? All right? Now, you are going to have to know some cubes and squares in order to do this. So if you're rocky on that, I would recommend that you go through and write down squares and cubes chart or two before we take the test, and I'll show you what I mean by that. Okay, just to kind of remind yourself, you can do it on the paper and it won't count as guess and check, but you don't want to think, oh my gosh, I don't remember what that means, right? But we need to know. Okay, yeah.
What number do you think we should know it up to?
2 and 3, and you should know it up to the 5th power.
Okay.
2 and 3 especially. Okay? All right. Now, okay. It can be any number, especially when you're taking the square root of any of those. The square root, you should know the square root of every number between 1 and 144. That's not that many numbers. So that's 1 and 12, right? Okay? Well, we'll talk about it. All right. That's it. Okay? Now, there is a note. However, if it's a square root, now really this happens with any even root, but we're only going to be talking about square roots on these. If it's a square root, you want plus and minus. That looks like a T, doesn't it? And you can write that as just plus over a minus. You've seen that notation before where you have a plus over a minus. That means plus and minus. You get the positive value as well as the negative value. Because think about it. If you have 9, 3 times 3 is 9, yeah? But isn't it negative 3 times negative 3 also positive 9? Yeah. So there are actually 2 roots. The positive one is called the principal root, and then there's also a negative root, right? And usually you only want the positive one. But, and on some questions, Ms. Brader was saying that you'll still get credit if you only write the positive one. But if you take a square root, just put plus or minus in front of it. It's never wrong. It's actually more correct, right? So you really want to do it right.
Plus or minus in front of ground, so they won't be like, you don't actually need that.
Exactly. They won't actually say that, yeah. Unless it's like a word problem, some kind of application problem where you can't have a negative. Right? If you put plus or minus and it's time, not going to happen, right? Because you can't have negative time. All right, so if it's an application, pay attention. But otherwise, put plus or minus. That does not happen with a cube. Right? Because think about it. 3 times 3 times 3 is 27, right? But negative 3 times negative 3 times negative 3 is negative 27. So it doesn't work with odd numbered. It only works with even ones, but you're only going to have squares, I'm pretty sure. Okay? Squares and cubes. So don't do it with cubes. So don't do it every time you take a root. Only when you're taking the what? Square or second root. Okay? All right, so let's just look at a couple of examples. Say you have x to the third equals 27. We know this is an equation. How? The equal symbol. Okay? No brackets, no fractions. Right? No like terms on either side. Is the x on one side by itself? Yep. What kind of equation is this? Index or exponential, because you have x to the third, right? So it's x to the third equals something. That's what they look like. Okay? So all I have to do is uncube that thing. Do the opposite of raising it to the third power, which is what? Taking a root. What root? The cube root. Remember, it's the same root as the exponent. But if I do it on that side, then what? To do it on the other side. On this side, it's easy. This index and this radical are opposites. That's why we're doing it. And just like 5 minus 5 gets rid of the 5s, cube root of a cube gets rid of both of those things. Leaves me just plain old x. How easy is that? There's no math involved there. Okay? You don't have to think about what root you're taking because the index will tell you. And when you do it, it just eliminates the index and the root. They're opposites, so they eliminate each other. Now, on the other side, though, the cube root of 27 means what number times itself, how many times?
3 times.
3 times would make 27. 3. Yeah. And do I write plus or minus on this time? Nope. Only when you have squares. So let's just think about squares and cubes.
How is the square
3 times 3 is 9 times another 3 is,
Oh, okay.
right? Okay, let's just talk about squares and cubes. If you take 1 and you square it, you still get 1. Cube it, you still get 1. 1 is everything, right? 2 squared is what? 4 times another 2 gives you cube of 8. Right? Do you see what I'm doing? 3 squared is 9 times another 3 is 27. 4 times 4 is times another 4 is
64.
okay. 5 times 5 is
25.
times another 5 is
125.
6 times 6 is
36.
times another one is
100. No, isn't it only 144?
I don't know, do it.
I'll do it.
72.
260.
Yeah, that's what I thought. Okay.
Oh, 36 times
Times 6. Okay? Now, that's probably as high as you need to go on the cube side. I don't think they're going to give you anything bigger than 6 to take the cube root of 6. No, because you don't get to use a calculator.
Always do that whole thing and never
But they will go all the way to 12 on the others. Right? So do you remember what a square is? Square means the number multiplied times itself. Cube means the number multiplied times itself, what? 3 times. Okay? So, how about if I have x cubed equals 216?
would be
And I'm going to make it more interesting. Negative 216. We got to get, is the x on one side by itself? Yep, except for the cube. We need to uncube it by taking the what? Cube root of what? Both sides, yeah. Over here it's easy. Gone, just as you x. Over here, the cube root of 216 is what? Is 6, but notice it was a negative, so that means it was negative 6.
Do you just drop the sign of it
If you're taking an odd root, if that number is an odd number, then the root is also going to be negative. Because you can't take the root of an even number. Is there any number times itself that makes a negative?
No.
But can you multiply 3 numbers together to get a negative? Yeah, but it has to be a negative to begin with.
So
Okay.
if it's cubed, you drop the sign.
Yeah, it stays negative. The cube root of a negative is still a negative. The 5th root of a negative is still a negative. The 7th root of a negative is still a negative. Right? See the pattern? Okay? How's that look? It's good? Okay. Now the second type is a little more complicated to deal with, but it's not hard if you just think about what you already know about cubes and roots, okay? So the second case is when the variable is in the exponent. Okay? Now again, you've just got the variable is in the exponent. I did the whole thing on the others. It's the second case from the one I listed
So
earlier.
the ones we just did were the first case.
That's the first case where all you're doing is unsquaring or uncubing. Now, I want to show you one more. I'm sorry, just one more. X squared equals 16. Now, x squared equals 16, that's actually a quadratic equation, isn't it? But I don't have to treat it as quadratic because it's x squared equals a number. It's a special case of quadratic. It doesn't have enough terms to factor it. Well, it does, but you don't worry about it. All I need to do is unsquare both sides, right? So the square root of x squared is what? X. The square root of 16 is what? 4. But I get what? Plus and what? Minus 4 when you take a square root. Okay? Want to do another one of those?
You know how we had the examples and then before that we had the isolate the square cube or whatever. That was all for case 1, right? Or just
No, it's all
any-
for anything. You get the variable
Right,
complete.
okay.
Get the variable complete by itself. Always.
Anything?
Yeah.
Examples
Okay.
for case 1.
All right. So look at, the first part of the notes were for anything, and then the second part was for case 1. All right, so what if I have x squared? Let's do this one. 3x squared equals, now I have to do some math.
This is for the second.
Is this for
12.
second case?
No, this is still the first case. I just wanted to. Is my x squared by itself? Guys?
No.
Is my x squared by itself?
No.
Nope, what's over there with it that I got to move first? So I'll divide both sides by 3 since it's multiplied, which gives me x squared equals 4. Now is my x squared by itself?
Yeah.
Yep. So I'd unsquare it by taking the square root of not just one side, but what? Which is going to give me, square root of x squared is just plain old x. What's the square root of 4? 2. But it plus and minus. So in other words, what are the square roots of 2? Because you had a positive and a negative one. Okay. So it is a quadratic equation, but it's a special case of quadratic because you have something squared equals just some number. Okay? Now, what if I had x squared equals 3x minus 4? Can I do that then? Is that a special case where I could just take the square root? No, because I have x squared and an x in it. So that's the one where you have to set it equal to 0 and factorize it and solve it, right? So make sure you know the difference. Okay? All right. Now, the second case is when you have the variable and the exponent. And what you have to do here is first, all right, if you have the variable and the exponent, you're gonna have to get both sides to the same base. Now write that down and don't panic. And then I'll tell you what that means. Right? You might be unfamiliar with the wording I'm using, but all right. So for example, if it's 2 to the x on this side, then I need this one side to be 2 to the something as well. Okay? So what you're going to do is break down whatever number's over there and see if you can make it 2 to the power. And it has to be the same base in order to make this work. Okay? Base is the thing that, so 2 is the base here. So this is the base. Remember, it's base. Oops. Well, that's weird. Okay, let me try this again. Yeah, I don't know what that's all about. It's base and exponent. The base is the thing you're raising the exponent to. Okay? So, if it's 2 to the x on this side, then it has to be 2 to the something on the other side. And they're never the same when it starts. All right? So you have to get it there. And you could also have 3 to the x. That's why I'm saying you should know the powers of 3 and the powers of 2. So let's just think of powers of 2. 2 squared is 2 to the third is 2 to the fourth is. All you have to do is multiply the previous one by 2, by the way, guys. Right? Don't do the math all over again. Just multiply the previous answer by 2 and it gets you the next one, right? Okay? 2 to the fifth is then 32. 2 to the sixth is blah, 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 blah forever. Do you agree?
Yeah.
So, say for example, we have 2 to the x plus 1. Now, do I care that it's x plus 1? No. Equals, okay, 32.
I remember we did this last year, but no, I definitely don't.
Okay? Now, I have 2 raised to some power, and my variable, my unknown, is in the exponent, right? So I can't just take the root of it, because I can't take the x plus 1 root of something. That doesn't make any sense, right? So what I can do, though, is first get both sides to have the same base. This is going to be really not well written over here. So can I turn 32 into 2 to some power?
Yes.
Sure. 2 to the what?
5.
So it goes 2 to the x plus 1 equals 2 to the what? 5th power. Do you see that these two bases are now identical?
Yes.
Okay. That has to happen. Okay? Then if that's the case, well, hold on a minute. So if that's the case, once the bases are the same, second, just set each exponent equal. Not to 0, just equal to each other. Okay, set the exponents. Don't put each. The exponents equal to each other. So in other words, you're gonna create a new equation that just is with the exponents. Because anything raised to the same power, you're going to get the answer, and you're looking for the exponent. You can get that by just taking the two exponents and set them equal to each other. So what's the exponent on the first one? What's the exponent on the second one?
5.
So then just subtract 1 from both sides. You get x equals what?
4.
There's your answer.
Oh, God.
Right? The hard work is this part.
What?
Changing the base. It's always the hardest part.
Can you not just take the base one time, put it there, and then figure out what the base is? Because would that always be the same?
Yeah, you need it to be a 2 to some power.
So you could just like put 2 and then figure out what the exponent is.
No, because you have to have that other number to solve it. Okay? All right? So all I did was just take the two exponents and put them over here to make a new equation. Let's look at another one like that. Okay? Let's say we have 3 to the x minus 4 equals... I don't know my powers of 3 very well.
27.
Pardon?
No, actually.
I mean, 27 is pretty small. Let's use 81.
8.
I'm just kidding. Oh, it's like, wow.
It could
have
have
been
been
8 if it was 2.
Okay.
No, it's 4.
Okay? Now, so think of powers of 3.
No. I mean...
3 squared is what?
Like, what's the dot in between? Is it meant to be times?
It's a minus, but I just...
But it just looks like a...
I went weird on... I'm sorry. Come on. Give me a break. All right. Yeah, I don't want to use 81. I want to use something else because that's going to give you a funky one. All right. 3 to the third is 27. 3 to the fourth is 81. 3 to the fifth is...
243.
Pardon?
Is it 243? Do you times
243? Yeah, 81 times 3. Okay. So let's use that. It's hard to do in your head. That's why I'm trying to make you remember it, right? And again, they're not going to get too carried away with these. They're not going to give you huge numbers that you have to raise to the power of 3. Because that's going to kill it. Now, can I turn 243 into some power of 3? You betcha. We better be able to. So it's 3 to the x minus 4 equals 3 to the what power? 5. Now I'm just going to take the two exponents and create a new equation. Okay? Yeah, I shouldn't have done minus.
3, 5, 9.
So that's going to give you x equals 9.
I said 8.
You did say 8. Yeah. If it had stayed the other one, it would have been 8.
So is it a good idea when you get something like this to write all the powers down so you can just like look and be like, oh look.
Well, you might not get one. So if you see it, yeah, write down the powers of 3. If you see that the original base was 3. Now, here's where it goes pear-shaped, guys.
Oh, this is when you don't know the original base.
Oh, let's just go back to this.
Will you always know the base?
What if they give you 9 to the x equals 27? Not 27. Yeah, 27. That's fine. Is there any power of 9 that's going to make 27? 9. Well, 9 times 9 is... 9 times 3, but right, raised to the power of 3 wouldn't be, would it?
No.
Because think about it. 9 squared is 81, so you're already too big, right? That tells me that I'm going to have to change not just this base, but this base. Okay? I can turn a 9 into a what? 3 squared?
Sure thing.
Okay? Can't you? Okay. So 9 becomes 3 squared raised to the x power. 27 can also be 3. 3 to the what?
3 to 3.
3 to the 3. Now do I have the same base? Yes. I had to change the base on both sides this time. Okay? So if you get a bigger number, it almost always means you need to change it into a 2 or 3. And it's never going to be something bigger than that, probably.
Wait, hold on. Can you keep that up there for a second?
Oh yeah, I'm not going to go anywhere. Now, we have to deal with this. Because I've got two exponents, right? I've got to put them together.
2 times.
Yeah. When you raise a power to a power,
3 to the power of 2x.
you just multiply it together. So 3 to the power of 2x equals 3 to the third. Okay?
Then you have 2x equals 3.
So then you get 2x equals 3. So the answer is 3 halves. So we were raising it to the 3 halves power. Don't worry if it's a fraction. Who cares? Do you have to do anything with it? No. Just write down the dang answer. Huh?
Is that 3 over 2?
Yeah, but just leave it. 3 over 2. Uh-huh. Yeah, leave it as a fraction.
Wait.
That's satisfying.
And the reason it came out to be a fraction is because 9 is a big number, and I was having it become a small number. And the only way to do that is with a fraction. All right? It doesn't matter what the answer is, just follow the process.
If so, when you're doing the division of x, you're doing the number that's on the side of the x, right? So you're doing the x by itself.
Well, you just, whatever these exponents are, you just, yes, you have to get rid of you have to get the number out away from the x. Okay, hold on. Here, right? And so when you do that, you simply when you have a power on a parentheses, you simply multiply the 2 exponents together.
There's like one step after that.
Okay? Oh, you're good there.
Yeah.
So what is my new exponent on this side then?
2x.
What is my exponent on this side?
3.
So I just put 2x equals 3 is my equation.
Oh, sorry.
You just set the exponents equal to each other. Yeah. So in other words, because the bases are the same, we don't care. We're looking for an exponent anyway, right?
That's cool.
So
I was
our
confused
yeah.
by the drawing.
Yeah, no problem. Sorry, I'm messy.
No, that's not your fault.
All right. Your variables in the exponent. So you're looking for an exponent. If you're looking for an exponent, that means we only need to use the exponents to find it, right? But it has to be the same base before that will work. Okay. Then of course, just solve the linear equation by dividing by 2. So we get x. So we get x equals 3 halves. Right. Because remember, it's 2 times x. The opposite of multiply by 2 is divide by 2. Yes, ma'am. Holly.
What if the 2